couple of weeks ago, we did a CNC This video where we showed us carving into a piece of hardwood. It was a Napoleon on a horse, and it was a really detailed carving. It came out awesome, and I've got a lot of people that are asking us to do a tutorial video to show how we made that file. So I'm going to do that right now. We're going to use VCarve Pro, but you could use VCarve Desktop. You have to use one or the other or Aspire because you need the 3D carving capability on this. So we're going to go ahead and create a new file. Now, my material is 9.5 inches wide. My model should scale out to about 12 inches tall, and my material is 1.25 inches thick. It's a single-sided job. We're going to zero the Z off the top of the material, and we're going to set the XY datum to the lower left corner. That's where we're going to put our end mill and set our zero reference on our machine when we start this job. So we're going to click OK. Next thing I need to do is we're going to bring in the actual 3D model. So we're going to go to File, Import, Component / 3D Model. Now I'm going to go in here and find Napoleon. Now, it's a really big file. There's a lot of detail in it, so it's going to take a minute or so to load. You can see the progress bar on the bottom of my screen. Now that the file's loaded, you could see this is the 3D carving file right here. And you can see this little tiny red rectangle. Well, that red rectangle represents my material, and this is how big the model imported. So you can see right here, the model imported at 206 inches by 267 inches, so it's pretty big, way bigger than we need. So what we're going to do is make sure lock XYZ ratio is checked, and we know our model width is our material width is 9.5 inches, so we're going to scale the model just smaller than that. So we're going to scale it to 9.25 inches, and that's going to give me a model height of 11.9 inches, and we're going to click apply. Now we're going to go ahead and center the model. Now you can see right here, see that there's a light blue area and a dark blue area. What we want to do is pull this model down into the material. So I want to set the zero plane. Now basically what this means is the zero plane, think of it like a sheet of paper that is invisibly being put in through the center of the model. And right now it's set to the middle. And what happens is when that sheet of paper goes through, anything above the paper is going to get carved. Anything below it is going to get discarded. So we don't want that. We want the full model to be in here. We don't need a zero plane in the middle. So we're going to grab this slider and we're just going to pull it all the way down. And then we're going to go ahead and click OK. All right, so here's our model. Looks pretty good, but we can make it actually pop a little bit more. So there's a lot of detail in there, but I think we could pull some more detail out of it. So what we're going to do is go to, if you were in the drawing tab, you want to click on the modeling tab at the bottom and double click the word Napoleon. Now our shape height right now, or our total model height, is 0.2236 inches, so it's just under 1/4 of an inch. We want to increase that. So I want to make it, because I have 1.25 inches, I want to leave some material underneath it, but I'd like to move this up to 6.25. And as soon as I do that, you'll notice the model pops a lot more. Like there's a lot more detail that shows up, and basically what we did was we pulled the model kind of vertically and added a lot more detail and depth to it by doing that. So you can adjust this number to anything you want. Your range is basically 0 all the way up to 1.25 inches, which is the thickness of your material. So in this case, I'm hovering right around the middle there. And I could go a little greater, and you'll see then the detail almost becomes too much. Although that does look pretty cool, but for what I'm looking to do here, I think I want to stick with 0.625 There we go. I like the way that looks. So now that we did that, we're going to click close. The next thing we need to do is we need to create a vector boundary around the model. So we're just going to make sure Napoleon is selected, and the third icon from the left, create vector boundary around selected component. So go ahead and click that. Now I'm going to bring the model to the center. Now what that did was it created see the purple dashed line, it basically created a vector all the way around the model. Now we'll use that a little bit later. So what I want to do next is I want to take the model, I'm going to highlight the whole thing. So I'm just going to drag from one corner to the other with my mouse button held down, and I want to go over to align model to material. It's basically going to center everything up. Okay, so now what we need to do is, actually now everything is all set. I do not really need to do anything else as far as drawing. Everything we're going to do now is going to be toolpathing. So I'm going to go ahead and click the toolpath tab, and then I'm going to pin it so it stays on the screen. Now, whenever you're doing a 3D carving model, you've got two processes you're going to do at least. You've got a roughing toolpath, which is going to remove, you're going to use a larger end mill and remove a bulk of the material faster. And then you've got a finishing toolpath, which is going to be a small ball nose end mill that's actually going to go back and forth and carve all the detail in it. So the first thing we need to do is set up our material. So we can click set here. It's a lot of things repeated from when we set up the job. So 1.25 thick, XY datum, lower left corner, Z0 on top. Now, this is kind of important here. This is the model position in the material. So this light brown area is the actual model, and the dark brown area is material under the model that's not going to get cut. Now, what I like to, because I'm using a piece of rough cut lumber, I want to bring the model down slightly into there, because what I want to do is make sure that I cut all that roughness off the top. So right now I'm actually going to set it. I can do it here by moving the slider, but I'm going to set this at 1/4 of an inch. Okay, so I'm basically going to remove 1/4 inch of material off the top with my roughing end mill. Then I'm going to rough out the model, and when I'm done, I'm going to have this material, which is roughly 3.75 or 3/8 of an inch below the model, that's going to be untouched. Okay, so I'm going to set my rapid Z gaps. Now on my machine, I like to run a clearance of 1/4 with a plunge of 0.2. And when I start the job, I want it to be at X0, Y0, but I want my end mill to be 1/4 inch above the material. That way, when my spindle starts up, I know it's not too close to the material, and I don't have to worry about it rubbing or anything. You could set that number to anything you want. I just find that 1/4 inch is good on my machine. Now, the other thing with the Z1 clearance here, now the way I'm mounting this board to the machine, I don't have clamps or anything in the way that I have to worry about. So if you are mounting your material with clamps, or anything else that kind of sticks above the material surface, you want to make sure that your Z1 clearance is going to be high enough so that when it does a rapid maneuver, your end mill is not going to crash into your clamps. So that's what this is for. Think of clearance as kind of it's a rapid Z, where every time the end mill has to move quickly from one spot to another to start carving a new location, it's going to go up to that height. But like I said, I don't have any clamps on here that's going to get in the way, so I'm not really worried about it. So I'm going to click OK. So the first thing I want to do is a roughing toolpath. Now, I'm actually going to use, in my tool library here, I have a Amana Tool 46352, which is a compression end mill. It's a 3/8 of an inch cutting diameter. I'm cutting this out on a Stepcraft Q series machine, a Q408. It's a 4x8 foot CNC, and I'm using a 3 horsepower ATC tool changer. So cutting through hardwood with a 3/8 inch end mill is not going to be a problem at all. I'm going to leave my step over at 40%. I don't need to go any smaller than that because we're just roughing. I'm going to leave my spindle speed at 18,000, and I looked up on the Amana website for this tool, and it told me I wanted to have a chip load between 5 thousandths and 7 thousandths. So by setting a feed rate of 200 inches per minute with a plunge rate of half that, 100 inches per minute, I get a 5.6 thousandths chip load, which is right in the middle of the range. So I'm good with that. Now the chip load's a relatively new feature that was just added to version 10 of Vectric programs, and I really like it because a lot of end mill manufacturers give you a recommended chip load range that you want to be in. So if it doesn't tell you exactly how fast to run it, but it tells you a chip load, then you can change numbers here. So if I make this 100, you can see my chip load goes down to 2.8 thousandths. So if I go back up to 200, I'm at 5.6. So that's a really neat feature right now that they've added. So we're going to go ahead and hit select. That's going to be the end mill we're using. Now, what I want to do here is I'm going to machine out to the material boundary. So basically, I'm going to machine the model, and then I'm going to machine right up to the material boundary here. But I want to actually extend that a little bit further because I want to make sure that when my end mill comes over, let me draw a little circle here, 0.375. Okay, so this is my end mill, right? And what I want to do, since this is my roughing end mill, and the white edge here represents my material, I want to make sure that when my end mill moves across, I'm actually clearing the edge of my material and bringing the end mill out here. It may take a few more seconds to machine, but it avoids me of having a really thin line along the edge that's not cut. And that way, when I come in with my ball nose, I know I've got at least a 3/8 of an inch clearance all the way around. Now, the board that I'm using is actually longer than what I set my material to at 12 inches. It's actually a pretty long board. I think it's like 4 feet long. So we're going to set this up, and then after this job is done, I'm just going to cut the board with a saw, and then I can use the remainder of it for a future job. Okay, so we're going to set a boundary offset of 3/8 of an inch, and on my machining allowance, I'm going to leave 20 thousandths on that my ball nose will have to come in and cut. I'm going to do a Z-level roughing strategy with a last pass profile, which will go all the way around to clean up your last pass. And I'm going to do this level by level along the x-axis, meaning I'm going to machine left to right on this. Now, the profile last pass, basically what that means is if I draw a rectangle here and then I go ahead and I draw 2 circles. Now, if I bring these circles, this is my end mill and it's coming right up to the edge, and then it goes back, you know, it comes to the edge, comes over, and then goes back, and then comes over and goes back again. So what ends up happening here is where the overlap is on the end mill. If we zoom in, you can see how you've got this scallop here that will not be cut because the end mill's round. So the end mill's going to move until it touches the vector boundary, and then you've got a 40% step over, so that's going to leave this little area right here uncut, and you're going to end up with a scalloped edge. So the last pass will actually, after it's done roughing, it's going to go all the way around the perimeter of the vector, and it's going to eliminate those scallops. Okay, so I just want to take a second to explain what that was. I always ramp plunge. An end mill is not a drill bit. It's meant to go in kind of at an angle into your material as opposed to plunging straight up and down. So a good rule of habit I have is always giving myself, you know, especially for an end mill this size, a 1-inch ramp. And that'll make sure that as it enters the material, it'll do it at an angle over a period of 1 inch. Just to illustrate that. So if this is my material, and here is my end mill, I've got a line that'll go from my end mill into my material that will be roughly 1 inch long. And so what's going to happen is instead of the end mill going straight down, it's going to basically follow this line until it gets to my first pass depth, and then it's going to continue. So that's going to put a lot less stress on the end mill as it plunges into the material. So that's what a ramp is going to do for you. Now, I'm just going to leave the name 3D roughing tool because I've only got one roughing toolpath, but you can name that anything you want. I'm going to click calculate. All right, so now in my material here, I'm going to change this from green plastic to a wood. Let's go mahogany. Okay, Now, if I preview this toolpath, you can see what happens here. I'm going to change the global fill. There we go. So you can see that the end mill comes over and it machines past my model boundary, or past my material. So it cleans it basically all the way out around the edge. And then I've gone down and removed a bunch of material here in the center. Now, if you want to get even more detailed on that, we can go back into here and we can change the pass depth, say from 3/8 of an inch to 1/4 inch, and then go ahead and recalculate that. Now what's going to happen is, if you preview it, you're going to see it step down a few more times, and it actually left some of these small pieces here. So that basically is just, it's doing more step downs, and it's leaving more material. It's actually leaving a little bit less material for the ball nose to go over after. So it's really up to you. I can do it at 3/8 of a pass depth, or you could do it at 1/4 inch. It really depends. Your machine is going to determine really what you do here. Our machine is really powerful, so getting through at 3/8 of an inch with hardwood is not a problem. But depending on your machine, if maybe you're only able to use an 1/8 inch end mill, and then you'll have to set your pass depths accordingly. So now that we've got a roughing done, we're going to go back and do a finishing toolpath. So we're going to click on that. Now I'm using an Amana Tool 46286, which is a tapered ball nose with a 1/8 inch diameter tip on it. So it's got a ball-nosed 1/8 inch tip. It's got a side angle of 3.6 degrees, and the tip radius is a 1/16 of an inch. It's a 3-flute end mill, and my pass depth is automatically set by the calculation in Vectric, and I want to set a step over of 5%. I want a really fine, detailed carving, and I do not want to have to do any sanding. So the smaller you set this number, the longer it's going to take to carve, but because the overlaps are so close together, it almost guarantees you don't have to do any sanding on your model. So it's kind of a trade-off. You could go up to 10%, 15%, or even 20%, but then you're going to have a little bit more finish work to do afterwards. So I don't mind having the machine run while I'm doing something else, but I do mind having to sit there and try to get in with sander in all these little crevices of a intricate 3D model. So I'm going to leave that at 5%. Going to set my spindle speed here to 18,000. And on this particular end mill, the manufacturer is telling me that I need to be between 2 and 3.5 thousandths of an inch. So if I go to a feed rate of 150 inches a minute, that's going to put me at 2.8 thousandths, which is right in the middle of that range. And so I'm pretty happy about that. What I'm going to do, though, to keep my carving going fast, I want to make sure that my plunge and my feed rate are set exactly the same. Now, what's going to happen is, as the end mill is moving across the carving, with a 3D carving, it's moving not only laterally, but up and down to carve the detail. So if this number, the plunge rate, is set lower, what'll happen is it'll move laterally through your material pretty fast, but then when it goes to do the Z maneuvers, it's going to slow down considerably. So I like to keep these two numbers the same. I'm going to click apply, and we're going to select that end mill. Now I'm going to do the same thing. I'm going to set my machining limit to the material boundary again, just like I did before. My end mill is an 1/8 of an inch, so I'm going to go slightly over that for a boundary offset. So instead of 125, I'm going to go 0.15. And basically what that's going to mean is the end mill is going to go to the edge, it's going to go straight down and then off slightly over to the side. And it's really not going to matter much, because remember, we set a boundary offset with the roughing end mill of 3/8 of an inch. So now that I'm only going 0.15, I don't have to worry about my end mill crashing into uncut wood, especially at the top and the bottom, because I made a 3/8 of an inch channel all the way around. And so I'm going to, this particular end mill is going to climb, I'm going to climb cut, and I'm going to do a raster, and we're going to go ahead and finish it. Calculation might take a minute or two depending on your computer speed. There's a lot of G-code being created right now for the carving because it's a really detailed model. So you can see it's processing right now. Okay, now all of the blue you see here is actual carving that your machine's going to do. All right, so if we go ahead and we preview this toolpath, you can see that's the way my end mill is going to be moving across. And I've got my model that's fully carved, and the detail looks pretty good on this. Now, if I want to get even more detail, which I did a test on this, and the 1/8 inch is going to be fine, but you could go down to a 1/16 inch diameter end mill, and of course it's going to take at least twice as long to carve, but you'll get a little bit more detail, especially in little tight areas like this. But again, my tests worked out fine with this end mill, and I'm really happy with how it's going to look. And you can see here that here's that channel that I removed with the roughing end mill, and when my ball nose comes over, it's going to come straight over. It's going to go down the side and out just a little bit, and then go back up and over again. So it's I don't have to worry about anything crashing. I always make sure that my roughing strategy goes at least the end mill diameter outside of my model to ensure that when I come back with a ball nose that I have plenty of clearance all the way around, and I don't have to worry about it hitting the edge and stressing out the end mill or the machine for that matter. So the last thing that we need to do here is I want to cut this model out. So this is where we needed that vector that goes all the way around the outside. So we're going to select that vector, and we're going to go to Profile Toolpath. Now, because the material is 1 1/4 inch thick, I've got an actual long reach. It's a Monotool 46590, which is a long reach 1/4 inch end mill. So it's about 4 inches long. And I use that when I have to get into tight spots, especially with a profile. And since on this job, the material is 1 1/4 inches thick, and then I've got my carving in there, I need to reach down at least to that bottom spot where I roughed out at 3/8 of an inch and remove the rest of the material. So this end mill is going to allow me to get in there without any problems at all. I'm running a chip load on it of roughly 3.3 thousandths, and this is all according to Amana's feed and speed calculator and what they're telling me I want to see for a chip load. So I'm going to go ahead and select that. And I'm going to start my start depth on this is going to be 0.375. So I'm going to go down 3/8 of an inch, and actually my start depth on this is going to be 0.5 inches, and my material is 1.25 inches, so that means my cut depth needs to be 0.75. I'm actually going to go about 20 thousandths over just to make sure I cut into my spoil board and I have a clean cut all the way through. So it's telling me it's going to do it in 6 passes. I want to make sure I'm machining outside of this vector. Obviously, if I go inside or on the line, I'm going to mess up my carving. So the vector represents the finished model, so I want to go outside that. I do not need to do a separate last pass on this, and I don't need tabs because my model is actually held down really well with double-side tape. And when I go through the last pass here, what I'm going to do is I'm going to edit my passes, and I'm going to set a last pass thickness of 40 thousandths. And 40 thousandths, 0.4, and apply. Now what's going to happen is these are all the passes that end mill is going to make, and when it gets to the bottom, the very last pass is just going to remove this small amount at the end, and that's going to make sure that when I cut through the model, I'm not putting a lot of stress laterally on the model or on the tape that's holding the material down. And so we usually call it an onion skin. Sometimes we go a little smaller than that. But on this material, I want to make sure I have at least 40 thousandths holding the model in place until I go ahead and cut that through. So I'm going to click OK. And I am going to ramp on this as well. Again, a 1-inch smooth ramp is fine. And we'll go ahead and calculate. Now it's warning me that my material thickness is set to 1 1/4 inch, but my maximum tool depth is 20 thousandths deeper. And it's just basically warning me that I should have some sort of a spoil board under there so I do not mess up the machine bed on my CNC. So that's an important warning you should pay attention to. Now I can preview that toolpath, and you can see it cleaned up the edge all the way around. And that is basically all there is to it. That is the finished model right there. And again, I'm holding it down on the back side with double-side tape. If I was using screws or clamps, in addition to that, I could come back here on the profile and I could do tabs. So I can add, say, I want to add 3/8 inch tabs that are, I don't know, 0.2 inches thick. Now, I can add tabs on this, but just keep in mind that the end mill, this white boundary is the width of my board. So you can't put tabs on the side because when the 1/4 inch end mill goes through, there's nothing for the tab to bite onto. So the only place I could put tabs here would be on the top and on the bottom because, again, I'm machining this out of a longer board. So if I put tabs there and there, then that's going to go ahead and keep that model in place if you're not using double-side tape. This probably will not illustrate very well because I don't have it drawn with a bigger, a longer end mill. I'm sorry, a longer material, but let's see what it looks like. Maybe you'll see a bit of the tabs. Yeah, you will. Okay, so it's going to show it. There's the tabs right there. So just, you know what, just for illustration purposes, let me make the height of this model 14 inches. And I'm going to click calculate. Did I do 14? No, I did 24. Let's do 14. And click OK. All right, so now let's go ahead and preview all the toolpaths now. You know what, we have to do one more thing. So now what we need to do is, because we made the material longer, we need to highlight everything again, go back over here and align it to the material. That'll center the job, top and bottom. So now I can go over to my, I want to recalculate all of the toolpaths because I moved the model. So I want to recalculate everything so that it's based on the new position. Okay, so now all my toolpaths are recalculated. I'm going to go back to preview. I'm going to click on the 3D view here. And let's go ahead and we'll do this step by step. So I'm going to reset my preview. I'm going to look at the roughing toolpath first. Then we're going to take a look at the finishing toolpath. And then finally the profile toolpath. And you can see here, just the reason I redid this is just to illustrate. So here are the tabs that are holding the model in place. And, you know, because the board is actually longer. So if I was using a piece of wood that was, you know, at least an inch or two longer than the actual project, I could hold clamps in all four corners and I don't have to worry about my end mill hitting them. And then the project will not move because these tabs will lock it in place. So then you'll have to just come back with a saw after, cut the tabs off, and then, you know, use a sander to sand the tabs down flush to the edge. So that's another way of doing it if you're not using double-side tape to hold your material down. So that is basically it. That's how you set up this job. You could replace this Napoleon with any 3D carving file. The process is very much similar. You just have to pay attention to your material height, and you got to make sure you scale that model down so it fits within your material boundary. And then your feeds and speeds are just going to be set based on your machine and the end mills that you're using and what the manufacturer recommends. So if you have any other questions, please don't hesitate to leave a comment below. And I thank you so much for watching, and I'll look forward to making another video for you soon.